Yep, evening everyone. Sorry for the delay there, doing some last minute checks on YouTube. Everything seems to be fine. Just going to fire up the stream now. There you go. People just let me know in live stream text if everything's working fine and then we'll get started with it. We're a couple of minutes late tonight, sorry about that one. A couple of last minute checks to do. Marvellous, we have confirmation. So welcome everybody, thank you for joining us for the final week of the backend topic of the month for devcord. It's the final week of backend, F's in chat all around. So let's have a look at what we're going to be covering tonight. Tonight we're going to be going over OAuth 2.0. It's okay, the cold sweat is perfectly normal. It's one of these very big, very scary, very complicated, but also very powerful authorization protocols that you need to know your way around, especially if you're going to be working with things like Discord bots. I'm going to be having a look at what it actually is, because it's a complete mystery for a lot of people, and we're also going to be having a very surface level look at some of the common usages of this protocol. I'm going to be taking another look into cause as well, because it still seems to mystify a lot of people, and I've actually realised while I've been working on a couple of side projects there's a few things I missed, so I'm going to cover those for you tonight. I'm going to be taking a deeper dive into cause, and we're going to be looking at some of the history of it as well, and some of the technical details involved in cause. So we're going to be having a look as well at DNS tonight, because this is another thing that you're going to be dealing with a lot when you're dealing with backend for a living. It's the thing that's always the problem. Inevitably, it's always DNS, it's never DNS, it's always DNS. So I'm going to have a look at the TLDR of what DNS actually is. I'm going to be having a look at how it works as well. So the first topic of tonight is OAuth 2.0. Again, let me reassure you, the cold sweat is perfectly normal. Depending on where you are in your career, that may have just terrified you a little bit. First thing that you need to know about OAuth 2.0 is that it is not a product, it is not a thing that you can just drop into a project and off you go, it's a protocol. So you aren't really going to be downloading a binary, you're not going to be installing a package, it's going to be a protocol that you will be responsible for implementing in your application. One of the other things that's worth knowing is that there is an entire RFC document out there for OAuth 2.0. It's one of those things that there is that many edge cases and that many strictly defined things that it's worth having an entire spec for it. So if you're the kind of person that gets a kick out of reading an RFC, by all means, please do go read it. I've posted a link for it in the backend resources. It's also rumoured to be the perfect fix for insomnia if you're struggling with that. The reason why OAuth is so insanely popular is that it's a battle-hardened, user-centric, scope-limited authorization protocol. So to bring that down to layman's terms, that means that this is a protocol that has been proven under really strict conditions in the field. A lot of the big boys use this. Facebook, Twitter, Microsoft, they all use it. It's also user-centric, meaning that it puts the user at the forefront of everything that it does. And with it being scope limited, it also means that you can restrict the access that an application has to a user's data. The user has to approve this access as well, which is why it's really good to implement. You are probably better off using a third-party service to power your OAuth implementation. I'll be upfront about this. It's one of these things that's very easy to get wrong, and if you get it wrong, there are disastrous consequences because you are limiting access to users' personal data. So I would recommend, if you're not completely comfortable with everything that's outlined in the spec, please do use a third-party service for it. A lot of them are very cheap. A lot of them will give you free credit to get started, like Okta. Please do use them. Okta, however you pronounce it, that one. So the main thing that I like about OAuth is that the user is king. The user decides whether you are allowed to access their data or not. This is one of these things that a user sees it, they immediately feel comfortable, so it's a good thing to implement. The user can also revoke the access to their account at any given time. This is something that you must be able to handle in your applications. Whether you're building an OAuth server or whether you're integrating with an OAuth-enabled service, you must be able to handle this. The user can revoke your access at any time for any reason, and you will be given no notice. You must be able to handle this. Now have a look at how. Unfortunately, I can't really explain a lot of the technical nuance of OAuth without getting into some insanely deep and murky territory. So it'll be on you to actually go and look into this yourself. But in a nutshell, here's how it works. An application wants to use somebody else's OAuth-enabled service. So let's say in this instance it's GitHub. And let's say that we're building an application that wants to use GitHub's API, which is secured by OAuth. In order to gain access and get some credentials, we have to pre-register our application with GitHub, meaning that we have to tell them about our application, we have to give them URLs of where it is, we have to give information about who created it, we have to provide things like icons as well. So the application, after registration, will receive a client ID and a client secret. So the client secret and the client ID will be stored on the application side, especially the secret. It's very important that they keep this secret because it's a secret. The user, when they click on a button like, say, sign in with GitHub or link your GitHub account, you'll have seen these all over the place. A lot of services provide them, like Facebook, Twitter, GitHub. There's a lot of services that use them. You've probably been using this all along without actually realizing it. But you'll click one of these buttons and you will be redirected off to that service. So we're going to assume, again, it's GitHub in this example. So we'll click the button, we'll be redirected to GitHub, and we will be shown a prompt. This prompt will tell us what app wants access to our account and what specifically it wants access to on our account. So we're going to assume that we've clicked allow and we've been redirected back to the application that we came from. If you have a look in the query string of the URL, you'll see that there's an authorization token which has been added. The application that we're redirected back to will take this code and it will send it back to, say, GitHub on the back end, away from us, and it will send it along with its client secret. What will happen then is that the authorization token will be validated, and if it is valid, if it's still within its lifetime, and it's not been tampered with, GitHub will then swap this out for an access token, which we will store in our application's database. Any future requests that are made to the API, on GitHub's API rather, will be made using this token. And at that point, we are acting on the user's behalf. It is not our application which is accessing GitHub's API, it is this user via us. So I've got a couple of notes, I've just kind of streamed past them all, unfortunately. Yeah, I covered everything. Woo, that was good. That was lucky. There are a couple of gotchas with OAuth that you need to be aware of. The first one is grant types. This is where everybody falls over when it comes to OAuth. There are so many different grant types which are basically workflows involved with OAuth. There's a whole bunch of these. Each one of these grant types is intended for a different scenario. So you've got some of them that are designed to be used with JavaScript applications like single page apps. You've got some for native mobile apps. You've got some for web apps. There's all kinds of these things. I think there's either 4 or 5 off the top of my head. The most common one that you'll run into, which is your traditional quote-unquote 3-legged flow, where you get redirected, then you get redirected back, then a token gets swapped. That is the authorization code grant. That's the most common one that you'll see. And that's the one that we're discussing here as well. I would thoroughly encourage you to do your own research on OAuth. It's one of those things where if you're trying to secure something with OAuth, I probably don't want to be involved giving you help with it. Please do your own research on it. There are a few links that I've posted in Backend resources. There is the official spec for this. I think there's the RFC as well. And I've also posted an OAuth 2 simplified link, which explains what this stuff is in human readable language. Again, it's very easy to get this stuff wrong. Please do use a third-party provider like Okta or Auth0. Again, these do offer some free tiers. They do offer free credit as well. Please do use them. Oh, there's another one I forgot about there, Firebase. They would also be a good choice to go with. I'd go with Okta, just out of personal preference. I've worked with them before. They are quite good. Quite infuriating during the initial setup, but they are a very good service. So why? Why exactly would you want to implement OAuth? Because you've heard about it being user-centric and all that. That sounds wonderful, but this also sounds like a gigantic pain in the ass, so why would I bother? It's a convenient way of restricting an application's access to user data. It keeps the user in control as well. The user is always aware of what is going on, and the user can always revoke the access rather, at any time for any reason. Oh yep, there it is, the user can revoke access. The access token that an application is... sorry, I completely tripped up there. So the access token that the application receives after it swaps the authorization token around will only allow access to that user's data. If they want to access a different user's data, they have to use a different access token. So it allows you to keep things very contained, very limited, very scoped. And as well as this, the access token will only allow data to the scopes the user approved in the first place. So when the user is taken to the OAuth prompt and they are shown the list of things, all the data that's involved, so they'll see the application that wants the access, they'll see things like the URL of the application where they can go find more information, and most importantly, they will see a list of scopes, usually referred to as permissions. So things like Facebook, for example, would say that this application wants access to your public profile, and it would give you information like, it usually tells you it wants things like your email address, your profile picture, some of your posts, things like that. Those would be the scopes / permissions that the thing wants access to. The user is always in control of what's actually accessed. The other reason why you'd want to implement this, it is a very mature protocol, it has been battle hardened, and it is proven. The biggest players in the industry use this thing and they trust it. I think that's a very good reason for you to do the same thing. Yeah, there it is, the big boys use it. So onto the recap and the questions. First of all, OAuth is a protocol, not a product. You are not going to find an off-the-shelf implementation you can just slam into your application and call it done. It'll be on you to implement something which matches the spec for it. Use a third-party provider as well. Unless you are extremely comfortable with the nuances and the technical challenges involved, please use a third-party provider. Again, it's very easy to mess this stuff up. You don't want to mess this stuff up. The user remains in control of all access at all times. They can revoke the access at any time for any reason. You must be able to handle this. And finally, it's very complex, it's very famously murky, and it's very difficult to understand is this protocol. Please check the backend resources for more information. So now I'm just going to have a quick skim through the questions. A lot of people seem to be liking the memes. Thank you very much. PHKDX says, I thought SQL was always the problem. It usually is. If it's not that, it's DNS. Strander asks, any recommendations for third-party OAuth providers? Those would be Okta, Auth0, and Firebase, just off the top of my head. There's plenty of them. Look for a few more. A couple of questions from YouTube. Why is it called OAuth 2.0? I can't remember off the top of my head, but there is a page on the OAuth 2 site which explains that. And I've already answered the one about third-party OAuth providers. Great stuff. So it looks like that's it for the questions. I can see someone typing, but I'm going to move on and I'll circle back around to it. So next topic, we're going to be having another quick look at cause. It's that thing which is definitely going to be testing your patience. It certainly tests mine. The first thing that you need to know about cause is that it's a security thing. So this means that all manner of compromises are being made which ruin the developer experience because security. Browsers get really nervous when there's things coming in from different sources. At one point in time, the web was all about the single site. Everything had to come from the site that you are currently looking at. Now, of course, this isn't the way that things work anymore. The web is very distributed. There's lots of services which allow you to send a request to them with some data and then something else comes back out of it, but this will always be somewhere else. So this is why things get a little bit tricky, because it's no longer a single site that you can depend on. You need multiple sites to get things done. One of the main reasons why cause is allowed to be so pervasive and so aggressive is that automatic downloading and running of code on a machine is the holy grail of malware. It's effectively remote code execution. If you can get another box running any code that you give it without checking, you've got full control over that box. That's why cause likes to step in and completely destroy your party all the time. Got a quick question. Is cause an acronym for something? Yes, cross-origin request sharing. Unfortunately, the modern web, like I said, is distributed. So cause is going to be around for a very long time, and we need to get good at handling it. Oh, on to the next slide, evidently. I ran out of points. So the first thing that you should know about cause is that it's all about the preflight. Everything is surrounding this preflight. It's all built into this protocol. So the preflight is just a standard HTTP request which is made to the service ahead of the actual request. So, yeah, sent before the actual request. It uses the options method as well. The reason it uses the options method is that this is something built into the HTTP spec, which allows you to query what can actually be done with a service without actually modifying the system state. So those of you that remember last week's talk will know that this means it's an idempotent method. When the preflight has successfully made the request, it checks the headers that are included in the response and makes sure that it can actually send the request from this origin. So if you're on site foo and you want to make a request to site bar, but site bar's CORS policy only allows requests to come in from site bars, the browser will step in and go, nope, can't do this, and it will just stop the request from going out. So yeah, it checks current origin is allowed to make this request, and it also checks some other criteria as well, which is another thing that seems to trip people up. They managed to get the origin check working properly, but then there's other things included in the request which aren't covered in the CORS policy. So are the headers permitted that you want to send? So you can actually limit which individual headers are allowed to be sent to your application in the CORS policy. If you suddenly decide that you don't want them specifying the content type anymore, you can just remove that from the allowed headers. All of a sudden, any request which includes a content type header is no longer allowed through. I think you're absolutely mad if you do this, but you can do it if you want. Is the request method permitted? This one's slightly more obvious, so that you can actually lock down which request methods can be made to your service if needs be. I've seen this trip a lot of people up actually in the past with the put method. They remember to include options, head, get, post, and delete, but they seem to forget about put, and then they're wondering why they can't update any data. So make sure that you check your actual request methods in your CORS policy before you go live, because these policies also get cached as well, so it just adds to the pain in the arse if you get it wrong. And the final thing that you can specify in the CORS policy is, are credentials allowed? And this is another one that seems to trip people up a lot. This doesn't mean can you use the authorization header. This means can you send cookies? And yeah, you wouldn't ordinarily think credentials cookies, but yeah, that's what that's for. So if you're using cookies for authentication with an API, make sure you've got that set in your CORS policy. So make sure you have a strategy in place as well for handling CORS. First thing you need to do is decide where you're going to handle the pre-flight response. So when this options request comes in to check your CORS policy and make sure that you're not a complete idiot, how are you going to handle it? Because there's a couple of different ways that you could do it. You could handle this the way I like to do it at the Nginx/Apache layer. So Nginx or Apache will see the options request and it will immediately respond with something. I usually just do a 204 with the CORS policy headers set. That way the request never actually reaches the application and it can stay nice and fast. The other way that you can do it is you can handle it at the application level. So you can actually specify a route which is listening for the options method, and then you can respond to it manually. This gives you full control over what's actually happening, but it can be quite slow as well because you are dealing with multiple requests. So bear that in mind. There is full control but can be slower. Finally, something that I have seen a lot of people suggest, npm I CORS. Stop it. Bad. If you don't actually understand what is going on and suddenly this thing comes along which magically fixes it, what are you doing? You don't understand the problem. Please understand the problem before you start implementing black box solutions. The CORS package is quite simple in what it actually does, but if you don't understand what it's doing, have you really solved the problem? The answer is no. So please do your research if you come up against CORS. Do your research, understand what the problem is, and understand what you actually need to do to fix it. Installing magical black box fixes, bad. Another thing which seems to trip a lot of people up is CORS in dev environments. Now, this one's actually caught me out a couple of times at work fairly recently. You're not building this thing directly on the server, I hope. I sincerely hope that you are not building this thing directly on the server. It can be really difficult to replicate the environment locally. There are tools available which can do it, things like Vagrant, which spin up virtual machines that are identical, but virtual machines are heavy. You don't really want to be working with these if you can help it. You might not be using something like Apache or Nginx in your local dev environment, because who wants to set that up on their desktop? Nobody. And that's okay. Don't worry about it. This does, however, lead to discrepancies between your local environment and the production environment. So if, say, in prod the application is sitting behind something like Nginx, and you don't have this in your local environment, If Nginx is suddenly responsible for handling something, like responding to a preflight, all of a sudden you don't have that in local, and things start to get a bit iffy. My solution for this is use Docker. The reason why is that you can just replicate your entire production setup in Docker, and you can just work on it exactly how it would work in production in Docker on your local environment. The other best bit about this is you can deploy your Docker environment to production, which I would recommend you doing if you're using Docker. Whether or not you could talk the boss into actually going ahead with that, that's on you, unfortunately. So I'll do a quick recap and then we'll pause for some questions. CORS is a non-negotiable and highly aggressive security mechanism. It's not going to be going away anytime soon. Learn to work with it. Stop installing black box packages which magically solve the problem. Learn how to fix it properly. There is no single command to fix a CORS issue. npmi CORS is not a single command that fixes CORS issues. I would recommend that you check enablecors.org because this has guides on just about every single server setup imaginable and how you can add CORS to it. Have a strategy for how you're going to handle a CORS preflight and make sure that you stick to it. You can either let Apache or Nginx handle it, or you can let the application handle it. It's up to you. Pick one, stick with it. Docker is a fantastic tool for solving this problem because you can replicate your production environment in a really nice, lightweight, fast way on your local machine, and if it works on your local machine, it will work in production because Docker, yay. Oop, so now let's get to head to DNS. So we'll pause for a minute just for any questions, and then we'll jump ahead to DNS. We'll jump ahead at the right time for once. No, got no questions on YouTube. Got no questions on Discord. Looks like we've got one coming in on Discord. Come on, Paula, no pressure. Ah, the pressure got to Paula. Stop typing. Yeah, so we'll jump onto DNS. We've got no questions. That either means I've completely confused everyone or I've done a decent enough job explaining it. So we'll jump onto DNS. This thing is definitely the root of all your problems. You're just not aware of it yet. It stands for the Domain Name System. And in a nutshell, it maps an IP address to a super friendly, memorable, human-readable string. So we'd say that something like doing a little bit of self-promo for a site that's not live. deadlyllama.com, one of my domains, will map to 5.9.14.220, which is the server that it's hosted on. If you can remember those numbers without writing them down and reading it a few hundred times, I admire you. But for all intents and purposes, that's what a domain does. It maps to an IP address. There's multiple types of records available when you're working with DNS. You've got things like an A record, which specifies an IPv4 address for a server. You've got the AAA, which is the same as a single A, but it's for IPv6. And you've also got things like the MX records for email authority. So that's specifying which server is allowed to send email for this domain. There's also a whole bunch of other types of records and the seemingly random custom ones popping up all the time. I'd be here all night if I went through the full list with you. The main issue that everybody seems to come up against with DNS is that it takes a lot of time for changes to quote-unquote propagate. And I will explain propagation in just a second. So how exactly does this work? It all sounds a bit like magic. At the core of the DNS system are what's known as name servers. Now, these name servers are what responds to a DNS query made by a user's browser with the correct IP address. However, sometimes it won't respond with the correct IP address, but it will respond with the IP address of another server to go and query. So it can very quickly turn into this infinite loop of, I don't know, ask this guy, and it will just keep going and going like that. When you own a domain, so when you buy one from a registrar, you can specify the name servers responsible for that domain. This is how you'd say I'm all over the place this evening. This is how you would say have Amazon S3, not Amazon S3, but AWS. This is how you'd get traffic to a domain into AWS, or to another server, or to another DNS provider, however you want to do it. But you've modified the name servers, suddenly you've changed the authority over who can actually say where this domain name points to. This is also how you specify your DNS provider. So an example for me, I like to buy my domains through Namecheap, but I don't like their DNS configuration. It's awful. So I use DigitalOcean for my DNS instead. So on Namecheap's site, I've set my name servers for my domains over to DigitalOcean's addresses. In essence, DNS is a massive chain of servers. So your browser will make a request. When you're trying to go to a domain for the first time, it will send a request to the first DNS server it finds, and it will say, where is this domain? That server will usually respond with, I don't know, ask this guy. And then you just keep doing and doing that until you actually get the result of the correct IP address for that server. That's basically how it works. It's a lot simpler than it sounds. The other thing to bear in mind with DNS is that there's a lot of caching that goes on at the OS level. You have absolutely no control over this, and purging it is a bloody nightmare. This can further complicate future changes to DNS records. So you've got a couple of questions. I'm going to wait until we get to the recap and then I'll get to those. Propagation. This is the single biggest headache you will deal with when you do anything with DNS. DNS is a global system that works on trust, so it relies on a hell of a lot of servers all reading from the same hymn sheet in order for anything to actually happen. Everyone must be aware of changes that are made to DNS settings globally. You can suddenly see where the problems are starting to occur. Publishing any change to your DNS records requires propagation. So if you imagine it like a ripple in some water, you make some changes to DNS, that's where the stone drops into the water. You have to wait for these changes to propagate out and out and out and out, and it just keeps going and going and going until basically every server on the planet is aware of the changes that you've made. This can take a lot of time. Propagation, basically the process of the changes you've made being pushed out across the internet. Thousands and thousands and thousands upon thousands of servers need to know about the changes that you make. Again, this takes time. Sometimes this can take up to 24 hours, sometimes it can take a lot longer, and you have no way of checking whether it's actually working without having multiple machines in multiple locations all hitting the domain at the same time. Some providers are very quick to receive updates and store them for DNS changes, like, say, Google's DNS. That one's famously very quick. So is Cloudflare's. Other providers, not so much. The other issue as well is that you have no control over what DNS server a user is actually using. I like to use Google's DNS. I know a few people in this chat like to use Cloudflare's DNS with the 4 ones. And a lot of the time, a user's default DNS server will be the ISP default one. Now, whether the ISP is quick to respond to changes in DNS, no idea. You have no control over it. As a general rule, measure twice, cut once, get it right the first time. I appear to be missing another point on my slide. But we shall move on to the recap anyway, and then we'll have a look at some questions. DNS is enough to make grown men cry. If you've never cried dealing with DNS, you are lying. Define DNS records to tell the internet what IP address corresponds to a domain name. So again, coming back to the Dead Llama example, deadllama.com corresponds to 5.9.14.220. You're not going to remember those numbers without writing them down. You might remember the domain name though. Changes to DNS records require propagation out across the entire internet. This takes time. Check twice, change once. If possible, check 200 times, change once. Rapid fire changes with DNS are not a thing. Don't bother. It doesn't happen. Get it right the first time and don't do it again. Users may be using DNS services that are slow to update. You have no control over this. So again, get it right the first time. So we've got a couple of questions. I think that's everything on my recap. I'm going to have a look at a couple of the questions. What are some of the security risks related to DNS? I know about something called DNS poisoning. How rare is an attack like that? DNS poisoning is a bit of a throwback there, actually. But in a nutshell, the way it worked was you'd effectively quote-unquote poison a user's local DNS cache. So in order to speed up the process of navigating from domain name to IP address, there's a lot of caching that happens. So instead of having to query a DNS server and then following this infinite chain of redirections until you actually get the answer, the actual answer will be cached. So the next time you go to that same domain, it just pulls the IP address out of the cache and off it goes. When you poison a DNS cache, what you tend to do there is you modify the result in the cache. So then instead of going to this known good site that it went to originally, it goes to a malicious one instead. One of the other issues with DNS is that it is a trust-based system. So again, it relies on a hell of a lot of people all singing from the same hymn sheet in order for anything to happen. It only takes one bad actor in that chain and everything can start going very, very wrong. Finally, as well, the bigger you are, the more damage your DNS can do. So imagine for a second that somebody inside Google, for instance, one of the world's highest traffic websites, suddenly decides that I don't like the way the internet works anymore. I'm going to send everyone to a malicious website instead of google.com. All of a sudden you have billions of potential requests a day which are being sent to something malicious. So it's relative to your scale, but there is potential for unbelievably bad amounts of evil to happen. So if you're in control of DNS, please do be extremely careful. Make sure you have two-factor auth. Make sure you have passwords that will take longer than the expected lifespan of the universe to crack, all this sort of thing. So one domain changes and it can take a month for everyone to update. Sometimes, yeah. It depends on a lot of different things in the chain. So if you've got, say, some users in your chain that are using like Google's DNS or Cloudflare's DNS, they'll probably get the change a lot faster than somebody on some unknown ISP on the other side of the planet. OpenDNS, yeah, that could be a potential option. I tend to go with Google or Cloudflare though. It's a note from Turbo there, it usually takes a maximum of 3 days for propagation. Yeah, 72 hours tends to be your absolute worst case. If it's not happened after 72 hours, something's clearly wrong and you have to do some more investigation. How do large applications or companies plan out DNS changes before launch? Due to the significant time delay, I'd imagine there's some planning that goes in, or do they have some backroom deals with the people that manage the DNS stuff? A lot of people like Google do actually have a fairly major part to play in the DNS chain itself, so I can imagine that that factors into a lot of their planning. But in terms of DNS changes, yeah, I can imagine that there'd be a large review process in place. I've not worked at somewhere like a tech giant, so I couldn't say for sure how it works, but I can imagine that it's basically the same as a very long code review, except for a DNS change. I got a point here from Were. You've mentioned the 4.1s at one point. How did they accomplish that? How come their domain name is the 4.1s? How come their server's IP address is the 4.1s? Cloudflare probably owns that block of IP addresses. Starting to get into some very big picture global internet scale stuff here. But my provider that I use for my servers, Hetzner, they have the 5 block of IP addresses, so 5xxx. It all depends on whether like ICANN and people have allocated it to you. What I'll do is, I've got a mate of mine who's really up on this stuff. I'll ask him about it for a decent explanation, then I'll post it for you. Because I'm not massively up on how they actually get the blocks of IP addresses. I know it's allocated by someone, I just can't remember who. Is there an easy way to refetch DNS records for a domain on a local machine? Not really. You probably have to purge your entire cache and then just start visiting sites again. Do you happen to know for SRV-based records, do those need to be supported application side? I can't say for sure off the top of my head, unfortunately. When it comes to defining ports, I just tend to listen on something like port 80, and then I'll apply whatever amount of complex, weird and wonderful rules are required in order to actually send it onto a different port. So sorry, Vice, I couldn't really say for sure. Anything to worry about regarding DNS on load balancers? Part of me wants to say yes, but part of me wants to say no. When it comes to load balancing, this will be something that I'd consider going on in your internal network. So this will be on the other side of going across the internet to that network. At that point, what you've got to worry about really is making sure that traffic gets sent to the correct set of load balancers rather than straight to the application server itself, which ventures really far outside of backend territory and really far into systems territory. If there's any DevOps people in the chat, if you could let Macro know about how this sort of thing would work, that'd be fantastic. Are we doing some final questions about backend at the end of the stream since the last one? Yeah, I could spare about 10 minutes and I'll see what I can do answering some general backend questions. I got another one from where you said that getting a server's IP can require asking lots of name servers. Is there a situation that it actually ends up in an infinite loop of name servers asking back and forth? I can imagine that there is, but I can also imagine that browsers have... Excuse me. I can also imagine that browsers over the course of the last 20, 25, 30 years have found some clever ways to deal with that scenario. There'd usually be something like a timeout built into the browser, so if it's not received a response back after some hilarious amount of time, it'll just kill the whole process. So a couple more questions coming in, no problem, we're happy to help. If you've got some general backend questions, I'll see what I can do to help. Just don't be posting blocks of code, because I don't have the brain power for it this evening. Sounds of people furiously mashing the keyboard. So you can look at events like DNS leaks where screw-up routing usually caused by an ISP as well. Yeah, like DNS hijacks, DNS misconfiguration could cause all kinds of havoc sometimes. Again, it's a trust-based system, so it relies on people being honest about it. Usually the way that that's enforced is that when you buy a domain, you gain access to the name servers, so you can specify who has the authority for that domain. Unfortunately, if there's something that's gone wrong, like name servers have been misallocated, that can cause a lot of chaos. If you fancy getting into some real big picture stuff, you can start having a look at BGP as well, which is like the layer above DNS in the chain. So if DNS is the roadmap how to get to the actual road, BGP is the people that make the map, basically. Hasn't Cloudflare had a few instances and some bad DNS groups leading to big outages? Yeah, that was... they've had a couple of instances like that. They've brought up all kinds of debates about monopolization of the internet, and it's... But yeah, they've had some problems with DNS misconfiguration, BGP configuration, misconfiguration rather. The last really famous outage that they had, I think it was first half 2019, one of the issues there was caused by a regex, which was checking for, I think it was parts of JavaScript running at the edge. And this regex was written rather badly. It managed to slip through all the automated testing, it slipped through the code review stages, and it just basically brought down half of Cloudflare servers. But the issue there, usually this wouldn't be a problem, because if you did that to your own servers, you'd just be knocking your own stuff offline. But because there's millions, if not billions, of websites that route stuff through Cloudflare, all of a sudden this is a really, really big problem. I'll find the post-mortem for that, and I'll post that in the resources, because it's a great read. It's also got the best name for a programming problem I've ever heard, which is called catastrophic backtracking. I just think that's a fantastic name for a problem. Apparently BGP is a construct by the lizard people to control the modern Earth. Yeah, I wouldn't say far off, to be honest. We've got a couple more minutes yet. Any more questions, please do fire away. Yeah, we had the one on YouTube about DNS cache poisoning. That's one I've already answered. What's your favourite part about backend development? Not writing CSS. That is my favourite part. That's literally my favourite part. I despise writing CSS. If you can show me something which is more counterintuitive and backwards in the world of programming than CSS, I will buy you a beer. Although on the flip side of that, I work backend for a living and I don't like writing SQL either. So that's why I use an ORM, which is also why I covered it in last week's stream. Nah, PHP is not more counterintuitive. PHP is fine. The only people that like to bitch and moan about PHP are people that don't work with it. Where do you see the future of backend development going? Do you see the structure of a backend front-end staying the same, or do you think there will be a lot more full-stack devs in 20 years? That's a good one. I think the way that things are going now, we used to have things like monolithic applications where everything was under one roof. And then we sort of broke it out into APIs and front ends like JavaScript apps. excuse me, yeah. And now we're moving into that, but more. So we're moving into more microservices. And depending on how large your ecosystem of microservices is, you need to actually start re-implementing basically the internet again in your little network. So I think it's Monzo in the UK, the first new bank in about 250 years. They write everything in Go. They use a lot of microservices, and they actually have to use BGP in their microservices network to actually find ways around the microservice network and to get the job done. Unfortunately, I can also see that running into a brick wall at some point, because one of the issues that Monzo talks about, which I hadn't really thought of, is you can't have developers that can have that entire ecosystem running on that machine. There's just too much stuff to run. So this means that custom tooling has to be made, and I can just see that just leading to more and more problems, really. We kind of end up going backwards then. But I think that for the most part, microservice ecosystems and sort of this big separation of concerns, I think it's going to continue, but we're going to move towards finding that sweet spot of breaking things up into lots of chunks and not doing it to a point where we can't even run the environment anymore. Do you think small companies and startups should start off with using microservices? God, no. I don't think anyone should start off doing microservices. I think if you do end up going down the microservices route, I sincerely hope you have a really good reason for going down that route, because you are adding all kinds of problems, not just into your development environments, but also into production. Because you've gone from maintaining one application like an API and a JavaScript app to maintaining theoretically infinite amounts of smaller applications. And as well as this, you've also got to deploy all of these theoretically infinite amounts of applications. So you end up spending an 80-20 mix of your time. Instead of it being 80% code and 20% deployment, it goes the other way. So you spend 80% of your time working out how to get this stuff into production. Microservices should be a product of necessity rather than desire, would be the way that I'd phrase it. Paula says, we may branch out into more specific developer positions. Quite possibly. We've already got, like in the world of DevOps, you get people that are hired for specific knowledge about things like microservices, deployments. And if you see specific roles for specific products like Kubernetes, that's definitely going to be here to stay. Sebs reckons we're already there. Quite possibly. We've got one from Zarios here. How do I actually start being a backend dev? Well, the simplest answer, which is the really unhelpful one, is to start building things on the back end. But the way that I'd probably recommend that you start is you start building a RESTful API. So if you have a look back at some of the recordings from the previous topics of the month, the previous streams from this month, I do a bit more explanation about what a RESTful API actually is, and then I'd recommend that you take those concepts and you start doing your own research as to how you'd actually implement that. So Neo reckons, I would say for smaller companies, there's still the option of using managed stuff and backends as a service like Auth0, Cognito. But yeah, otherwise completely agree. Yes, it's going to be a weird one, because there's always this battle between, do we go third party or do we build it ourselves? Because the third party is expensive, building it yourself is expensive, but third party continues to be expensive afterwards. So it's a tricky one. Business needs are going to determine it. I reckon I'm going to give it probably about 45 more seconds and then we're going to kill the stream. Paula's just put a link to a developer roadmap in live stream text. Can confirm that's a pretty good roadmap. Definitely go give that a read. And yeah, it looks like that's everything. Just going to wait for Sebs here really quick. Marvellous, that's everything. Well, thank you all very much for tuning into the final stream for Backend Topic of the Month. I'm not entirely sure what's happening for the next one. You might have to start bugging the staff about that one. But hopefully it's going to be more of the same, and if I do another Topic of the Month in the future, I'll let you all know. So thank you very much. I'll post those links to the OAuth things in the backend resources, and I shall catch you all on a future topic of the month. Bye bye, everyone.